So now we're going to use these tangent lines that we've been finding to approximate values of some functions, and usually they're curve functions. This is pretty theoretical stuff, so it might take a while to understand. You might have to rewatch, ask questions, but here we go. So we're going to start with this graph, the graph of f of x equals the square root of x. And it looks like this. I have it here somewhere. There it is. It's what the square root of x graph looks like. So you're familiar with that. We're going to determine what the tangent line to that graph is at x equals 4. So I did that for you. That's pretty simple. You might want to try that yourself. Just pause this video and try it. But it comes down to this. That's the point slope form, and I rewrote it in slope intercept form just so we can see how it's graphed. So I'm going to go back to Desmos, and here's that graph. Actually, in Desmos, you can plug it in like this in point slope, so you don't have to convert it. That's what the graph looks like. So the square root graph is a red graph, and the tangent line is a blue graph. One thing you'll notice is if you look at this point of tangency, you can't tell them apart. They're obviously they intersect at a point of tangency, but even very close to the points of tangency here and here, you can't tell them apart. That's how close they are. Now, obviously, if you look far away from the point of tangency, then they split apart, so they're not alike at all. So the purpose of this section is using the tangent line, because lines are easy to use, to approximate the value of a curved function like the square root of x at a point very close to the point of tangency, because it will work there. It won't work all the way over here because they're far apart. So that's the whole theory behind this. And I'll show you that again. See this red graph? That's the graph of the square root. And this blue graph is the graph of the tangent. And we're going to approximate what the square root of 5 is. So we're looking right here at 5. But we're not going to plug it into the square root because I don't know what the square root of 5 is. I'm going to plug it into the tangent line. That's going to be easy because it's a linear function. And these values, they look like they're the same, but down here I zoomed really, really close into 5. And you can see there's a small difference between them. The tangent line's above the actual graph. It's not very big because look at the scale over here. They're very close. So I guess we'll do it. So if you want to figure out what the square root of 5 is, which I don't know, I do know that the tangent line which we just drew, which was y equals 1/4 x plus 1, is always very, very close to the square root graph. So instead of taking the square root of 5, let's just plug 5 into the tangent line. One-fourth of 5 is 5/4, which is 1 1/4, which is 1.25, plus 1 is 2.25. So that's this point right here, the tangent line point. That's 2.25. You can see it. But that's very, very close to the actual square root of 5. So that's all there is. That's it. And if you don't believe that, I actually had my calculator do the square root of 5, and it was 2.236. It is very close to 2.25. It's off by about a little bit more than 0.01. So that's the whole deal. I'll stop this right now, and I'm going to show you another kind of instructional video just so you get the handle on it, and then I'll give you some examples.